This is the third part of Isro-Vssc Technical Assistant Electronics Engineering previous year question paper with detailed solution. The exam held in 2021. The post number is 1425. Up to question number 40 we discussed in the previous two videos. Question number 41. Power dissipated across R3 in the circuit shown below is 2 watt. When terminals A and B are connected to a DC source, the power dissipated in R2 is, answer is option D, 0.4 watt. Given the power dissipated in resistor R3 equal to 2 watt, we know that P equal to V into I, or we can use the other equations I square R or V square by R. Therefore, equate P equal to V square by R. Substitute the value of P 2 watt equal to V square by value of resistance R3 is 8. After solving we get V equal to plus or minus 4 volt. The voltage drop across both R1 and R2 is 2 volt each, since R1 and R2 are connected in series. Therefore, power dissipated in R2 equal to V square by R. Substitute the values of V and R, we get the answer. The power dissipation is 0.4 watt. Question number 42. In FIR filter design, which of the following windows gives least peak side lobe level, assuming equal width of the windows? Answer is option A, rectangular. In signal processing, a finite impulse response filter is a filter whose impulse response or response at any finite length input is of finite duration because it settles to 0 in finite time. This is in contrast to infinite impulse response, that is IIR filters, which may have internal feedback and may continue to respond indefinitely, that is usually decaying. The impulse response of an nth order discrete time FIR filter, that is with a lasts for n plus 1 samples and then settles to 0. FIR filters can be discrete time or continuous time and digital or analog. Here is a summary of Windows design in case of FIR filters. Windows name main lobe and side lobe. For rectangular, the main lobe is 4 pi by m, side lobe is minus 13 dB. For Hanning window, main lobe is 8 pi by m and side lobe is minus 32 dB. For Hamming window, main lobe is 80 pi by m and side lobe is minus 43 dB. For Blackman window, main lobe is 121 pi by m and side lobe is minus 58 dB. Next, question number 43. The transfer function of a linear system is the, answer is option C, ratio of the Laplace transform of the output and that of the input with all initial conditions 0. Transfer function of a control system is defined as the ratio of the Laplace transform of the output variable to Laplace transform of the input variable, assuming all initial conditions to be 0. It is also defined as the Laplace transform of the impulse response. If the input is represented by R of s and the output is represented by C of s, then the transfer function will be transfer function equal to C of s divided by R of s. Question number 44. The Laplace transform of a unit ramp function starting at t equal to a is, answer is option e raised to minus as by s square. The Laplace transform f of s of a function f of t is defined by Laplace transform of f of t equal to f of s, which is equal to integral 0 to infinity e raised to minus st f of t dt. This is standard form. We know that Laplace transform of unit ramp is 1 by s square and we know the time shifting property of a Laplace transform, that is Laplace transform of f of t minus a equal to e raised to minus as f of s. From the given equation, we need to get the Laplace transform of a unit ramp function starting at t equal to a, that is t minus a. That is Laplace transform of t minus a equal to e raised to minus as divided by s square. Question number 45. Which of the following is the final value of the impulse response of the system whose transfer function is 2s plus 1 divided by s raised to 4 plus s cube plus 16s square plus s? We know that final value theorem. A final value theorem allows the time domain behavior to be directly calculated by taking the limit of a frequency domain expression. That is, the final value theorem states that the final value of a system can be calculated as f of infinity equal to limit s tends to 0 as f of s. F of is the Laplace transform of the function. For the final value theorem to be applicable, the system should be stable at the steady state. And for that, the real part of the pole should lie on the left side of the S-plane. Here, f of s equal to 2s plus 1 divided by s raised to 4 plus s cube plus 16s square plus s. Since no poles lies on the right half of the S-plane, the final value theorem is applicable. F of infinity equal to log s tends to 0 as f of s. Substitute the value of f of s, that is f of infinity equal to log s tends to 0 s into 2s plus 1 divided by s raised to 4 plus s cube plus 16s square plus s. Taking s common from the denominator and cancel both. Then after apply s tends to 0, we get f of infinity equal to 1. Question number 46. Which control method is best suitable to eliminate steady state error in closed loop response? Answer is option B, integral. Integral controller reduces both the steady state error and the relative stability because it adds one pole to the system. Integral control is based on the principle that controller's output should be proportional to both magnitude and duration of the error. The controller's output will continue to change its value until the error is 0. This property enables integral action to eliminate offset error automatically. That is, it is sometimes called as automatic reset controller. Also, a smaller amplitude causes a slower rate of change of the output. The features are, it is memory based controller. This increases the type of system. This controller reduces steady state error and also improves the steady state response. Question number 47. The following table gives damping ratio and output characteristics. Identify the correctly matched row. Row number 2 is the correct one. That is 0 less than delta less than 1 is the underdamped condition. The damping ratio is a system parameter that can vary from undamped eta equal to 0, underdamped eta less than 1, through critically damped, that is eta equal to 1, to overdamped eta is greater than 1. The figure shows the 3 damped situations. First one, overdamped, eta greater than 1. This is the equation of aperiodic motion, that is the system cannot vibrate due to overdamping. The magnitude of the resultant displacement approaches 0 with time. Underdamped, eta less than 1. This resultant motion is oscillatory with decreasing amplitudes having a frequency of omega d. Ultimately, the motion dies down with time. Critical damping, eta equal to 1. The displacement will be approaching 0 in the shortest possible time. Question number 48. Which transfer function represents a stable system? Answer is option D, all the above. The stability of a linear closed loop system can be determined from the location of the closed loop poles in the S-plane. The system is stable if all the roots of the characteristic equation lies on the left half of the S-plane. That is, if all the roots have negative real parts, then the system is said to be stable system. Since for all the systems given in the option, the poles lies on the left half of the S-plane, that is, if all the roots have negative real parts, hence all the systems are stable. Question number 49. A common emitter amplifier has small signal gain of 65. What will happen if the emitter bypass capacitor is removed? Answer is option A, small signal gain decreases. When an emitter bypass capacitor present, then while performing AC analysis, the effect of emitter resistance got nullified because in AC analysis, the capacitor behaves as a short circuit. Effect of removing emitter bypass capacitor, voltage gain decreases, input impedance improves, current gain improves, bandwidth increases since gain bandwidth product should be constant. Common mode gain decreases, CMRR increases, that is common mode rejection ratio. Note 1. Effect of a bypass capacitor, coupling capacitor only present in low frequency region. Effect of internal capacitor of transistor, that is C mu and C pi present at a higher frequency. During mid frequency region, no effect of capacitors present. For differential gain, there is no effect of bypass capacitor. So therefore CMRR increases only because of the decrease in common mode gain. That is, we know CMRR equal to AD by AC, that is difference mode gain divided by common mode gain. Question number 50. In an RC phase shift oscillator using BJT, oscillations happens at the frequency where the frequency network shift the phase of the amplifier output by. Answer is option C, 180 degree. In an RC phase shift oscillator, the phase of the feedback voltage is shifted by 180 degree with a 3-stage RC phase shift network. We can see from this figure. Single RC network gives 60 degree phase shift. The inverting amplifier produces a 180 degree phase shift. It has a fixed frequency and is used at lower frequency applications. Question number 51. For a second order system, the undamped natural frequency is 3 radian per second and the damped frequency is 2.4 radian per second. The damping ratio is, answer is option 0.6. Damped natural frequency of a second order system is omega d equal to omega n into root of 1 minus eta square, where omega n is the natural frequency and eta is the damping ratio. Given that omega n equal to, that is natural frequency equal to 3 radian per second and damped natural frequency omega d equal to 2.4 radian per second. Substitute in the equation omega d equal to omega n into root of 1 minus eta square. Rearranging, that is omega d divided by omega n equal to root of 1 minus eta square. Square both LHS and RHS. We get eta equal to root of 1 minus omega d by omega n whole square. Substitute the values of omega d and omega n in the equation. We get eta equal to 0.6. Question number 52. Networks A and B are connected by two conductors and it is required to find out the currents and voltages in network B. For this purpose, network A can be replaced with its Thevenin equivalent circuit unless. Answer is option C, it has magnetic coupling to B. Thevenin theorem, also known as Helmholtz-Thevenin theorem, states that any linear circuit containing only voltage source, current source and resistance can be replaced by an equivalent combination of a voltage VTH in series with a single resistance RTH connected across the load. The simplified circuit is known as the Thevenin equivalent circuit. Thevenin theorem is applicable to passive element, independent current and voltage sources. If network A has a magnetic coupling with network B, then there will be a voltage controlled source being controlled by a current of network B and this is not allowed. There is a limitation of the Thevenin theorem that there should not be any controlled sources controlled from some other circuit part of the circuit. So magnetic coupling to B will prohibit the replacement of a network A with its Thevenin equivalent circuit. Therefore, network A can be replaced with its Thevenin equivalent circuit unless it has magnetic coupling to network B. Question number 53. What is the largest positive value that can be represented by an 8-bit 2's complement number? 2's complement representation or sign notation. The first bit tells about the sign. The name comes from the fact that a negative number is a 2's complement of a positive number. The convention is that a number with a leading 1 is negative. That is, MSB is negative. MSB is 1, which means negative, while a leading 0 or MSB is 0 denotes a positive number. In an 8-bit representation, we can represent a number from minus 128 to plus 127. Question number 54. If 1, 0, 1, 2 of 3 equal to 1, 1, 2 of x, the value of radix x is, answer is option B, 5. To convert any number which is in a different base to a decimal number system, we use binary weighted representation. If the two numbers are equivalent, they will remain equal in other number system as well. Converting both the sides to decimal and then equating, we get 1 into r square plus 1 into r plus 2 into r raised to 0 equal to 1 into 3 raised to 3 plus 0 into 3 raised to 2 plus 1 into 3 plus 2 into 3 raised to 0, that is r square plus r plus 2 equal to 27 plus 0 plus 3 plus 2, that is r square plus r minus 30, which is equal to 0. We can simply solve this quadratic equation by rearranging this. This r square plus 6r minus 5r minus 30 equal to 0. Taking the common terms outside, we get r into r plus 6 minus 5 into r plus 6. Taking the common terms r plus 6 outside, that is r minus 5 into r plus 6 equal to 0. Here we get the values of r is r equal to 5 and r equal to minus 6. The valid value of r equal to r is 5. Question number 55. Shifting the register content to left by 2 bits can be used to implement. Answer is option A, multiplication by 4. Shift registers are sequential circuits that are used for storage or for the transfer of binary data. Shift register takes the data present on the input and shift it to the out once every clock cycle. Every shift in the register content to the right by 1 bit position is equivalent to dividing the original number by 2. Every shift in the register content to the left by 1 bit position is equivalent to multiplying the original number by 2. This is explained with the following example. Consider the example. Let the original content of a 4-bit left shift register is 0010, which is equal to 2 in decimal. Shifting the content of the registers to the left by 2-bit position, the new content becomes 1000, which is 8 in decimal number system. Clearly, the original number is multiplied by 4. Consider question 56. If A and B are logical variables, A bar represents complement of A dot B represents AND operation, A plus B represents OR operation. What is the value of A bar into A bar plus B bar? Answer is option C, A bar. The given expression is A bar into A bar plus B bar. Taking into the bracket, A bar into A bar equal to A bar into B bar. A bar into A bar is A, that is 0 into 0 equal to 0, or 1 into 1 equal to 1. That is A bar into A bar plus A bar into B bar. Taking A bar common, A bar into 1 plus B bar, we get answer is option A bar. Boolean algebra laws. Identity law. AND form is 1 dot A equal to A, OR form equal to 0 plus A equal to A. Null law. 0 dot A equal to 0, 1 plus A equal to A. Idempotent law. A dot A equal to A and A plus A equal to A. Inverse law. A dot A dash equal to or A bar equal to 0, or form A plus A bar equal to 1. Commutative law. B dot A equal to A dot B, or form B plus A equal to A plus B. Associative law. A dot B dot C equal to A dot B dot C, or form A plus B plus C equal to A plus B plus C. Distributive law. A plus BC equal to A plus B into A plus C, or form A into B plus C equal to AB plus AC. Absorption law. A plus A into A plus B equal to A. This is the question here given. Or form equal to A plus AB equal to A. De Morgan's law. AB whole bar equal to A bar plus B bar, and A plus B whole bar equal to A bar plus B bar in OR form. Question number 57. Program counter in a microprocessor is used to store the next instruction. Is not the correct answer. Option D, store the address of the next instruction to be executed, is the correct answer. The explanation. Program counter, it acts as a pointer to the next instruction to be executed and always contains the 16-bit address of the memory location of the next instruction. It is a 16-bit register as 8085 has 16 address line. The program counter is updated by the processor and points to the next instruction after the processor has fetched the complete instruction. Next one is the stack pointer. It is a 16-bit register that stores the address of the top of the stack memory. The value of the stack pointer is decremented by 2 in push operation. It will increment by 2 in pop instruction. Accumulator. It is an 8-bit register which contains 8 flip-flops. It can store a maximum of 8 bits of data. The importance of the accumulator is that in most of the 8-bit arithmetic and logical operation, the microprocessor will always take the 8-bit number from the accumulator. Next question, question number 58. Which is not true about an interrupt? Answer is option C. After servicing the interrupt, the main program is suspended. An interrupt is a condition that halts the microprocessor temporarily to work on a different task and then returns to its previous task. Interrupt is an event or signal that requests the attention of the CPU. This halt allows peripheral device to access the microprocessor. Whenever an interrupt occurs, the processor completes the execution of the current instruction and start the execution of the interrupt service routine or interrupt handler. That is option A is correct. Non-maskable interrupt are those which cannot be disabled or ignored by microprocessor. Trap is a non-maskable interrupt. It consists of both level as well as edge triggering and is used in critical power failure condition. Therefore, option B is also correct. Interrupt service routine or ISR is a program that tells the processor what to do when the interrupt occurs. After the execution of interrupt service routine, control returns back to the main routine where it was interrupted. Option C is wrong. Interrupts can be classified into various categories based on different parameters. Hardware and software interrupt, vectored and non-vectored interrupt, maskable and non-maskable interrupt. Hardware interrupts. When microprocessor receives interrupt through signal through pins or hardware of microprocessor. The 5 hardware interrupts in 8085 microprocessor are INTR, RST 7.5, RST 6.5, RST 5.5 and trap. Software interrupts, those which are inserted in between the program, which means these are mnemonics of microprocessor. The 8 software interrupts in 8085 microprocessor are RST0, RST1, RST2, RST3, RST4, RST5, RST6 and RST7. That is option D is also correct. Note, that is extra points. Vectored interrupt, those interrupts which have fixed vector addresses, starting address of subroutine, and after executing these, program control is transferred to that address. Non-vectored or scalar interrupt, those in which vector address is not predefined. The interrupting device gives the address of subroutine for these interrupts. INTR is the only non-vectored interrupt in the 8085 microprocessor. Maskable interrupt, those interrupts which can be disabled or ignored by the microprocessor. These interrupts are either edge or level triggered as they can be disabled. ITR, RST 7.5, RST 6.5, RST 5.5 are maskable interrupts in the 8085 microprocessor. Question number 59. An ideal 6-bit DAC with a 0 offset gives output voltage of 0.1 volt for an input of 000010. What is the output for input 001010? Answer is option B, 0.5 volt. Given digital input 000010 and a VA, the output of a DAC VA equal to 0.1. The decimal equivalent of 00010 is 2. We know the output of a DAC VA equal to R into D, where R is the resolution of DAC and D is the decimal equivalent of digital input. Substitute the values in equation 1, we get 0.1 equal to R into 2. Therefore, after rearranging, we get the value of R equal to 0.05. Now, for input 001010, the decimal equivalent is 10. Therefore, VA equal to 0.05 into 10, we get an answer of 0.5 volt. The last question of this video is 60th one. Which of the following gate has low if and only if all the inputs are high? Answer is option C, NAND gate. Consider the other options. NOR gate. NOR gate has high output when A and B is 0. For all other conditions, the output is 0. For XOR is a coincidence non-coincidence gate. That is, if both the inputs are different, we get an output of high. For NAND gate, the output is low when all the inputs are high. For AND gate, the output is high when all the inputs are high. Thank you.